Morning mist settles low over the Black River, pooling between dark trunks that rise straight from black water. The scene feels quiet and timeless. Knees of bald cypress break the surface like ancient markers, and the air carries a sense of age that is hard to name but easy to feel. These trees stand patient and enduring, their massive forms shaped by centuries of floods and droughts. Those familiar with this region recognize that this is not a normal forest. It is a living record that reaches back more than 2.5 millennia, a rare survival in a world where most ancient woodlands were erased long ago. Geography is permanent. The floodplains of eastern North Carolina were shaped slowly by rivers that wandered and spread across flat ground. Long before modern settlement, these rivers carved low channels and left wide swamps that were hard to reach and harder to drain. That physical setting mattered. It decided where people could go and where they could not. It decided which forests were easy to cut and which ones were left alone. Industries shift and land use changes, but the shape of the ground remains. In the case of the Black River, that shape protected something extraordinary. These ancient trees stand as weathered monuments across the landscape, their rounded peaks holding 2,600 years of geological memory. The ridges of their bark preserve evidence nowhere else maintains, layers of wood recording vanished storms and changing skies. While younger western ranges boast sharp summits, these enduring giants display the quiet power of true survival. The landscape holds itself with the dignity earned through deep time, each valley carved by forces working across ages beyond human comprehension. Bald cypress trees are not fragile. They are built for extremes. Their wood resists rot. Their trunks endure long periods underwater. Their roots spread shallow and wide, gripping soft ground that shifts with every flood. Tree rings show that these trees survived centuries of wet years and dry years, heat and cold, storms and calm. Fire scars show that some endured burns that would have killed other species. When cut or damaged, they can send up new growth from stumps, refusing to disappear. This toughness is not an accident. It comes from evolutionary traits shaped for the southeastern coastal plain, where water levels rise and fall and soils stay saturated for long periods. Many forests around the world could not handle those conditions for long. These did. The Black River floodplain offered stability that few places could match. Soil built up slowly. Sediment settled gently during floods instead of being ripped away. The river moved at a measured pace, spreading water across wide flats instead of cutting deep channels. That slow rhythm allowed trees to grow old without being undermined. It also made large-scale logging difficult. Heavy equipment could not move easily through deep mud and standing water. As nearby forests were cleared, these stands remained. They were lost everywhere except here, tucked into places that resisted quick profit and heavy disturbance. Scientific work in these swamps revealed just how rare these survivors are. Tree ring studies showed ages far beyond what most eastern forests could offer. Some bald cypress individuals have lived for more than 2,600 years, placing them among the oldest known trees in eastern North America. That makes these stands not just old, but globally significant. They preserve climate records in their rings that stretch back long before written history in this region. Droughts, floods, and temperature shifts are recorded year by year in wood that still stands upright. Nowhere else in this region does a living forest hold such a long, unbroken memory. Conservation efforts recognize this value late but decisively. Since the late 20th century, large areas along the Black River have been protected from logging and development. What began as small parcels grew into tens of thousands of acres under protection. Careful mapping later showed that old-growth areas were far more extensive than first believed, nearly 10 times larger than early estimates. This discovery changed how the forest was understood. It was not a small relic. It was a broad system that had quietly endured. This endurance sets these woodlands apart from many others. Around the world, ancient forests were cut for timber, cleared for farms, or burned repeatedly until old trees vanished. In many regions, only fragments remain. Here, continuity matters. Continuous growth means soils developed slowly under forest cover. Organic layers built up and stayed in place. Root systems and microbial communities remained intact. The forest did not reset again and again. That long stability is preserved nowhere else in the same way across such a large area of eastern North America. The landscape holds this ancient knowledge quietly. Massive trunks show twisted grain where growth adjusted to stress. Fire scars close and heal, layer after layer sealing over damage. Growth rings narrow and widen in response to changing conditions, telling a detailed story of the past. These trees remember centuries of storms that passed before towns existed. They witnessed climates shift gradually rather than abruptly. Their patience is written into their form. Comparisons make this clearer. Many mountain forests farther west, like parts of the Appalachian Range, are younger, shaped by recent uplift or frequent disturbance. Their trees may grow tall, but few reach such great age. Tropical forests can be ancient in species, but individual trees rarely survive for millennia due to competition and disturbance. Coastal forests in other parts of the world were cleared early because flat land was easy to access. In contrast, these North Carolina swamps combine difficult terrain with a species uniquely suited to it. That pairing is unique to this region. Geological determinism plays a quiet role here as well. Rivers carved floodplains long before humans arrived. Those floodplains decided where wetlands formed. Wetlands decided which species could survive. And those species, in turn, shaped soil and water movement over centuries. Settlement patterns followed higher, drier ground nearby. Roads avoided deep swamps. Development clustered elsewhere. The forest remained because the land made it inconvenient to remove. The terrain decided. Authority supports every part of this story. Studies published in leading scientific journals confirm the ages, the climate signals, and the regeneration patterns. Tree ring scientists cross-dated samples from multiple trees, matching patterns to rule out error. University teams dated many different trees to make sure the results were correct. National Geographic documented these findings as well. Independent lines of evidence converge on the same conclusion. These groves represent the longest verified continuity of any wetland tree community on Earth, preserved through geography rather than chance. The trees visible today look ordinary at first glance. Gray bark and sparse needles cover their forms. Broad bases rise from dark water. But measurements changed everything. Scientists use special tools to take small cores from the trunks to count the rings. One tree passed 2,600 rings. Another reached a similar age. These were not guesses. They were exact counts. Each ring marked one single year. The result made these cypress the oldest known living trees in eastern North America. That fact alone sets this place apart, making it unique to this region. Scientists then asked how this happened. Bald cypress evolved traits that matched this landscape perfectly. Shallow root systems spread wide rather than deep, gripping soft, flooded ground. Cypress knees rose from submerged roots, allowing oxygen to reach tissues where soil lacked air. Thick bark resisted rot and insects. Even when storms snapped trunks, the trees could sprout again from stumps. In a place where water drowned competitors, These trees endured. Tree rings recorded the proof. Dry years appeared as thin bands. Wet decades showed wide growth. Severe droughts like the year 1502 left marks still visible today. Flood-heavy periods that killed oaks and pines barely slowed cypress growth. Fires failed to spread and soak soils. Hurricanes stripped branches but left trunks standing. The trees survived climate swings that erased forests across drier ground worldwide. That resilience remains extraordinary. Seeds added another layer of protection. Bald cypress seeds float. Floodwaters carry them across silted flats. When water drops, seeds settle into fresh mud already rich with nutrients. Regeneration happens without gaps. No clearings form. Canopy cover stays continuous. In many forests, disturbance resets growth. Here, floods renew it. Only here does disturbance strengthen continuity instead of breaking it. The floodplain itself plays a central role in this story. Sediment builds up slowly along the Black River. The river meanders gently, not violently. Banks resist collapse. Soils remain deep and stable. In uplands, erosion strips ground bare. Along coasts, rising seas erase forests. In this quiet interior lowland, balance held. The land guarded its living archive. Human history added to that protection. Native American use remained light. Canoes passed through. Small harvests occurred. Large-scale clearing did not. Later, remoteness mattered. Swamps resisted roads. Logs sank. Axes moved elsewhere. Across the southeast, roughly 99% of old-growth forests fell. Here, distance and water served as guardians. Continuous canopy survived where access failed. Comparisons highlight the rarity of this survival. Western forests grow fast but burn often. Northern forests reset after ice. Tropical forests rot quickly. These cypress grew slow and steady. While the Rockies rose only 80 million years ago, these floodplains supported trees alive before the Roman Empire. While the Himalayas still rise and fracture, these swamps remain quiet and patient. Endurance, not height, preserved knowledge here. The landscape itself shaped human patterns nearby. Rivers carved routes long before people arrived. Settlements formed where land rose slightly above flood. Roads avoided swamps and followed ridges. Terrain decided movement. Even today, maps reveal how water still dictates access. Geography remained the silent planner. But endurance has limits. These groves did not survive ancient mass extinctions. Their story fits within the last 10,000 years. Stability allowed continuity. Now that stability wavers. Saltwater pushes inland. Sea levels rise. Ghost forests appear where cypress once stood. Even the most resilient systems face boundaries set by changing oceans. That reality does not lessen the achievement. It clarifies it. These trees survived floods, droughts, storms, fire, and neglect because the land allowed it. The floodplain offered the right balance. The species met it with matching traits. Together, they created something remarkable. They formed a living record of climate, water, and time. The dignity of these forests lies in their restraint. They do not dominate skylines like mountain peaks. They do not announce themselves loudly. Instead, they stand quietly, massive trunks rising from still water, patient and resilient. Their beauty is subtle but striking, revealed in texture and form rather than height alone. Rounded bases flare into buttresses. Bark carries the marks of centuries. Light filters through open canopies, reflecting off dark water below. In the end, ancient cypress woodlands reveal something rare. They show how permanence can exist even in low, wet places often dismissed as empty or marginal. They preserve lessons about climate, resilience, and time that younger forests cannot hold. They remind observers that some landscapes guard their treasures not through isolation by distance, but through conditions that demand respect. These enduring trees remain because the land allowed them to remain. Every tree ring tells a story of survival. Tree ring records show these forests endured extreme dry periods, including severe droughts around 1502 AD and again near 1580 AD, when rainfall dropped for years at a time. They also lived through colder conditions during the Little Ice Age, when growing seasons shortened and storms intensified. Faster-growing trees failed during these periods. Bald cypress remained. Their survival came from slow growth in poor soils, where competition stayed low and stress was constant. Longevity under adversity became the defining trait. Physiology explains much of this endurance. Bald cypress evolved thick, rot-resistant bark that protects living tissue during floods and fires. Their roots tolerate long periods underwater, aided by knees that help move oxygen in flooded soils. When storms or fire damage the trunk, stump sprouting allows the tree to rebuild its canopy without starting over. This continuity preserves the stand even after disturbance. Growth slows, but life continues. Studies of these trees show that slow growth correlates strongly with long lifespan, especially in nutrient-poor wetlands. These traits evolved specifically for the southeastern coastal plain, where water levels rise and fall unpredictably. Floods arrive not once a year, but many times, sometimes lasting weeks. Drought follows. Fire moves through drier margins. Competing species struggle to adapt to such swings. Bald cypress tolerates them. Over centuries, this tolerance allowed groves to persist, while surrounding forests shifted, collapsed, or regenerated repeatedly. Microhabitat stability played an equally important role. The Black River floodplain accumulates sediment very slowly. Banks do not erode fast, channels shift little. This stability limited uprooting and burial that would kill long-lived trees elsewhere. Remoteness also mattered. Dense wetlands restricted access, protecting these groves, while nearly 99% of similar old-growth forests across the region were logged. Low overstory competition and natural fire suppression in saturated soils further reduced stress. Only here did all these conditions align. Stand near the Black River today, and the feeling is unmistakable. Trunks tower quietly. Knees break the surface like stone. Reflections ripple and fade. The forest feels patient, steadfast, and dignified. These ancient cypress hold truths about survival that younger forests never learned. The landscape remembers. Geography remains permanent. Industries shift. Populations move. But the floodplain still lies where the river slows. The soil still gathers silt. Water still returns. In that repetition, the land preserves wisdom written ring by ring, year after year. North Carolina's bald cypress groves stand as enduring proof that some places hold time itself, guarded quietly by roots in dark water. In the case of the Black River, that shape protected something extraordinary. These ancient trees stand as weathered monuments across the landscape, their rounded peaks holding 2,600 years of geological memory. The ridges of their bark preserve evidence nowhere else maintains. Layers of wood recording vanished storms and changing skies. While younger western ranges boast sharp summits, these enduring giants display the quiet power of true survival. The landscape holds itself with the dignity earned through deep time, each valley carved by forces working across ages beyond human comprehension. Every raindrop from the Blue Ridge to the coast follows paths set millions of years ago when the land first rose from the sea. Geography is permanent. These floodplains have stood as a shield while industries rose and fell. The closing truth carries quiet power. These swamps do not claim immortality. They do something more impressive. They show how life can persist, adapt, and remember when land remains stable. Individual trees live longer than entire human civilizations. Generations link across thousands of years. Climate history stays written in wood. Geography remains the constant force beneath it all. In a world shaped by change, the Black River bald cypress stand as enduring witnesses, holding ancient knowledge in living form and reminding observers that permanence in nature comes from place, not from illusion. Geography is permanent on human timescales. These geological forces were active hundreds of years ago and remain active today. Industries change and populations shift, but the underlying landscape stays constant. Geographic patterns we see today were determined by ancient forces beyond human control. Understanding these permanent geological forces helps explain why certain patterns exist in the landscape. Geographic features we observe are not random. They are the direct result of ancient processes that science has now fully confirmed.